All right, so let's talk about some triangle theorems. So we've talked about how to classify triangles by their angles. We have acute, right, and obtuse triangles. We've talked about how to classify triangles by their sides, scalene, isosceles, and equilateral. And so now what we're going to do is we're going to focus on a couple things that are always true. That's what a theorem is, something that's always proven to be true for triangles. And the first one is the triangle sum theorem. And so the triangle sum theorem says that angle A plus angle B plus angle C equals 180 degrees. Basically, if you add the three angles, and every triangle has three angles, that's where triangle comes from. So if you add all three angles together, you'll always get 180 degrees. So now I have a video that proves that in every triangle, all three angles add up to 180 degrees. Hey guys, I just want to show you a proof of the triangle sum theorem. So here I've got just your average triangle that I've cut out using paper and scissors. And so it's an obtuse triangle. I don't think any of the sides are the same. I guess maybe these two are, so possibly an isosceles triangle. But I wanted to show you that all the angles add up to 180 degrees. So what I'm going to do is I'm actually going to rip off the angles that I've cut out, the triangle I've cut out. I'm going to rip off two of the angles. And you can do any two angles if you want to try this on your own. You can draw any triangle at home and check this for yourself. And then what I'm going to do is I'm going to place those angles next to the third angle. So this is the obtuse angle that I didn't cut out. And so if I place these angles next to the third angle, what you see happen is they actually form a straight line. And we know straight angles measure 180 degrees. So if angle 1 plus angle 2 plus angle 3 add up to a straight angle, that proves that there's 180 degrees. All three angles will add up to 180 degrees in every triangle. The next theorem that we'll talk about tomorrow is the triangle inequality theorem. And this theorem says that the two shorter sides of a triangle have to add up to be larger than the third side or greater than the third side or the largest side. That's why it's called the inequality theorem. We'll talk more about this tomorrow. But for right now, let's focus on the kind of problems you're going to see in your homework tonight. So the first thing that you're going to want to do in your homework is you're going to want to solve for x. The second thing that you'll be asked to do in the homework is to identify what kind of triangle it is, just like you did on your last homework, which we did acute, obtuse, or right triangles, scalene, isosceles, or equilateral triangles. So let's look at example A. What I'm going to do is I'm going to write an equation in order to solve for x. And my equation for example A is going to look like this. X plus 32 plus 48 equals 180. We know there's 180 degrees if you add the angle measures up. Now, if you add the two angles that you already have, that you already know, we have 32 and 48, and that's going to make 80. So x plus 80 equals 180. And then I can solve it from there. By subtracting 80 from both sides, we get x equals 100. Now, I know that seemed like extra work, and some of you may have just said, why don't I just take a calculator, do 180 minus 32 minus 48? And that works. But it's not going to work for problems down here like example C and example D. So I like using methods that always work, and so we get x equals 100. Now, because we know x is 100, we can classify this as an obtuse triangle because we know we have one angle measure that's greater than 90. And since none of the angles are the same, none of the sides will be the same. So a triangle that has no sides, no congruent sides, is called scalene. So this would be an obtuse scalene triangle. None of the sides are the same. In example B, we have also a triangle where we have to solve for x. So my equation is going to be x plus 81 plus 25 equals 180. We add the two angles that we already have. 81 and 25 makes 106. And if we subtract 106 from 180, we get 74. So x is 74. Now, we don't have, if this is 74, we don't have any angles that are larger than 90, so this would be an acute triangle. If none of the angles are larger than 90 or equal to 90, because that'd be a right triangle. And then none of the angles are the same either. So if none of them are the same, then we know it's, again, a scalene triangle, because if none of the angles are the same, none of the side lengths will be the same. For example C, this one looks more complicated. It's not that complicated at all, actually. I'm going to do the same thing I did for the last two examples, which is write an equation. If I write out all three angles, which is the x plus 28 angle, the 90-degree angle that we're given right there, and then the other x angle, I still know that because it's a triangle, they're going to add to 180 degrees. So now I'm going to combine my like terms. I've got an x and an x. 1x and 1x makes 2x. And then I've got a 28 and a 90. And 28 plus 90 is 118. And then I know that's going to equal 180. So now I just solve this like normal. I'm going to subtract 118 from both sides. And so that's going to be 62. I'll go ahead and write that down here so you can see the steps that I'm doing. So 2x equals 62. And then now I'm going to divide both sides by 2 to get x by itself, which is what we want. And so 62 divided by 2 is 31. So we know that x is 31. So that makes this a 31-degree angle. 31 plus 28 is 59 degrees. And then we have this 90-degree angle. So when I go to classify this triangle, I know that none of the angles are the same, so it's scalene, and because none of the sides will be the same. And then because I do have a 90-degree angle, that would make this a right scalene triangle, because we do have an angle that's exactly equal to 90, so right scalene. And then on the last one here, example D, I'm going to do the same thing. X plus x minus 35 plus 43 is all going to add up to 180. I'm going to combine my like terms. 1x and 1x makes 2x. Negative 35 and 43. Now this is negative. This is a minus 35. So when I combine these, I have different signs, so I'm going to subtract. 43 minus 35 is 8. I have more positives than negatives, so it's positive 8. So I'm not just going to add 35 and 43 because it's negative 35. And that's going to equal 180. Subtract 8 from both sides. 180 minus 8 is 172. And then I'm going to divide by 2. And that's going to be 86. So divide by 2 and x equals 86. So if this is an 86-degree angle, then the other angle would be 86 minus 35, which is 51 degrees. And so I have got no angles that are 90 or above, so it's an acute triangle. And again, none of the angles are the same, so I know it's scalene. If two of the angles are the same, then two of the sides will be the same. It would be isosceles. And of course, if all three angles are the same, then all three sides would be the same, and it would be equilateral. So now I'd like to look at a homework question. There's two homework questions like this one, but I want to look at one of them from tonight's homework. It's number 7. Number 8 is just like this one. It says, tell whether the triangle can have the given angle measures. And then the angle measures we have here are 76.2, 81.7, and 22.1. And then it says, if the triangle cannot have those given angle measures, write a new value for the first angle in the box so that the angle measures form a triangle. Now, what I'm going to do is I'm just going to add these up. So 76.2 plus 81.7 and then 22.1. Now, if you have a calculator, that's going to save you a lot of time here. I'm going to go ahead and just add these together right now. 2, 7, and 1 makes 10. Carry the 1, drop down the decimal point. 1 and 6 is 7, plus 1 is 8, plus 2 is also 10. And then I've got 1 and 7 makes 8, 8 and 8 makes 16, plus 2 is 18. So all three angles add up to 180. So a triangle can have these given angle measures, but they still want you to put something in here for the box. Well, because 76.2 is the perfect angle, right? It adds perfectly with these other three. I'm just going to go ahead and copy the 76.2 down into the box. Now, if I were to get something like, I don't know, let's say I added these together and got 178, if I can write it here, 178.9. Let's just say that's what I got, for example. Then what they would want me to do in the box is they would want me to correct the first angle. So if I know triangles are supposed to add up to 180, and I would get 178.9, that means I would need to add basically 1.1 degree onto this triangle so it adds up to 180. So if, this is a big if, right? If I add the three angles together and I get 178.9, then I know that I need to correct the first angle by 1.1 degrees. I just need to add 1.1 to that, and that's what I would put here in this box. In this problem, I don't need to do that because it equals perfectly 180 degrees. But that's what they're going to want you to do for number 8. If it doesn't add up to 180 degrees, they're going to want you to figure out, okay, well, how many more degrees do I need? Or maybe you have too much and you need to subtract some. And you'll just add it or subtract it from that first angle so that all three of these angles add up to 180.